Hey there, everyone. My name is Ryan Schul. Welcome to my data science and machine learning channel. So in today's project, I want to talk about probability sampling and non-probability sampling. So probability sampling is basically taking every data point that has a known chance of being selected, and you're taking a subset of that population. Non-probability sampling relies more on rules, convenience, judgments, and this can introduce bias, but sometimes it's very practical. If you want to take a subset of a population and you want a specific subset, then we have to use non-probability sampling. Okay, so let me create a hypothetical dynamic data set right here where you're going to look at age, ID, gender, income, region, and education. And keep an open mind, this can be anything, right? Okay, so I'm just creating this data set. Honestly, I was a little bit too lazy. I don't want to go online and look for this myself. So I just created it using some Python code, and these are actually random samples, right? Random integer, random choice over here. So it's not a real data set, but I think it will illustrate the point pretty nicely. So in probability sampling, we could do simple random sampling, and each data point has an equal chance of being selected, like picking names from a hat, right? You just go into a hat, you pick a name, and that is random sampling, right? It's very simple, but you could miss specific patterns in the data set when you do this, right? So it's really case-by-case basis how you do this. We have data sample n equals 100. Remember, we started with 10,000 data points. We were picking 100 by default, and the random state is just random, right? So random is random, and we're displaying this, and I'm looking at the top 5 records. If I get rid of the head, we will see that we have 100 rows, okay? 6 columns and 100 rows. Again, this is just random, HEAD. I'll go back to that. And we're just picking names from a hat. That's all this is. So stratified sampling is when you look at the population and the population is actually divergent into subgroups. These are called different strata. Strata like stratosphere of the clouds, right? Like different layers or different levels or different subgroups based on key characteristics. It could be customer age, it could be product category, it could be whatever, right? But the samples are drawn from each to ensure representation of these subgroups, okay? This is ideal for classification tasks with imbalanced data. So we have sklearn model, and we're using train test split to group by education, and the group keys equal false, and we're taking a fraction. This is 10% of the original data set, and again, it's based on strata or different levels or different parts, and we're grouping by the education feature or the education column in this case, okay? So we're taking a certain subset of the original subset over here. Everything was random. Now we're looking specifically at education and grouping based on that. So we can do systemic sampling, right? So these data points are more selected at regular intervals, every 10th record, or every 20th or every 100th, right? It's really up to you. This is case-by-case basis, but it's very efficient, but it risks bias if the data has hidden patterns, okay? So we have to be aware of this. So if I hit Control-Enter, you can see the sampling here. So this is systemic based on the iLocation of the data frame, right? This is data frame, iLocation, and we're picking all the features over here, right? But it's systemic and basically just taking a subset of different regular intervals. So every 10, right? So every 10, K is 10, and we assign the K right there. So we can do cluster sampling. So clustering is very popular in the data science world. There's 3 main pillars of data science. You have regression, you have classification, and you have clustering, right? These are the 3 main types of projects that we usually work on. So you can use clustering to do your sampling, right? So probability sampling based on clustering involves a population that is grouped into clusters. It could be geographic regions, it could be education patterns, income groups, genders, right? Well, there's just 2 gender here, so male and female. It could be age brackets, right? You can group into multiple clusters of age brackets, like very young people, middle-aged, more senior people, and then very senior people, right? So there's all kinds of ways to do this. We will use data. This is the data frame. We're looking at region in this country, in this example, sorry. And we're looking at unique region, and we're clustering into these groups. So Control Enter to refresh this, and we have our cluster sampling right here. So there's another way to do sampling too, right? Again, the whole process of sampling is taking a subset of the population, right? If we don't want to work with the entire population, we can take a subset and do our analysis based on that, right? It's like sometimes these data sets are so massive, it could be billions or tens of billions or hundreds of billions of records in the data lake, and we can't analyze every single one. But if we take a subset of that entire population and group it into either probability or non-probability sampling, we can run our analysis. If we don't do that, maybe the model will never run. Maybe it will never get started. Maybe it will never kick off, and we don't have anything to show to the boss, right? Like the boss wants to see some kind of result. There has to be something done. There has to be some transaction. There has to be some kind of process that runs here, right? If you go to the boss and say, hey, it's going to take 15 weeks for the model to run, he's going to come back and say, no, get out of here. It's not going to take 15 weeks, right? You have to figure out how to make the model run. So you take a subset of the entire population. So we can do a specialized technique like reservoir sampling, which allows us to look for streaming data where the data set is infinite. It just keeps coming and coming and coming and coming. Like think about posts on Facebook or messages on LinkedIn or new videos popping up on YouTube, right? Like I heard this crazy statistic. I think every 1 minute there's 100 hours of video posted to YouTube. Let me sometimes I go off on these tangents. I'm sorry. How many new videos, on YouTube each day? 3.7 million. This translates to 1,800 videos uploaded every minute. So 500 hours are uploaded every minute. Okay, so I was off. I thought it was 100 hours. It's increasing. Like I think it used to be on 100 hours at some point. It must have been 100. But it's increasing. It's 500 hours of video are uploaded every minute. So can you possibly analyze all these videos? No. I have several videos, or I have a handful of videos to demonstrate how to analyze the text or extract the text from a YouTube video and then convert that into some kind of machine learning project, right? I did that in a couple of my videos. But there's no way that you can analyze every single video that's coming onto YouTube. If you got 500 hours, what did it say? 500 hours of video every minute? That's crazy, guys. That's crazy. So in this kind of scenario, like you have to use a specialized technique like reservoir sampling. You have a reservoir, you create a user-defined function. This is the definition of the function. This is the name of the function. You create a reservoir, which is actually a list. Anything in Python with a square bracket is a list. And you iterate through the list. For I, this is the iteration right here. Numbers in stream. These are the streams. These are the 500 videos coming in. 500 hours of video coming in. 1,800 videos every minute. That's a crazy statistic, man. This blows me away when I see things like that. Okay, so you have to take a subset of the entire population. There's no way you can analyze all these videos, right? But when you take a subset, you can say, okay, here's a new Taylor Swift video. Here's a new video from Coldplay or whatever, and you can analyze the text and you can do some analysis on that. But you have to take a subset of the population. You can't analyze the entire population because that's impossible, right? So another way to do sampling is undersampling. We can look at balance by downsampling the majority class. So you see this a lot in things like anti-money laundering, credit card fraud, things like this. Like there's very few cases of somebody stealing your credit card and charging $100,000 on the credit card, right? If the thief takes the credit card, that is very unusual, but that does happen, right? So if you want to try to prevent that from happening, you would set up a machine learning model and have a couple of videos on this, how to prevent fraud, right? But if you have most of the cases, which are legitimate transactions on credit cards, on people's credit cards, transactions, you can't shut those down. You can't turn it off and nobody can buy anything, right? But you do want to prevent the fraud from happening. So you have to look at the fraudulent activities, right? But you can't train the model on like, this is always the normal case, right? You have to undersample from the normal transactions of credit card swipes, but oversample from the fraudulent transactions, right? If somebody takes your credit card or there's some kind of money laundering or some kind of like drug cartel is trying to send money to some kind of offshore bank account or something like that, right? You want to oversample. Down here is another case. So undersampling from the majority class, oversample from the minority class, right? Sometimes you have to do this to get a probability sample for the machine learning model to understand what is actually happening here and to detect this kind of fraudulent activity or a drug cartel is sending money to an offshore account, right? That's what you want to flag. That's what you want to understand. That's what you want to try to prevent, right? So these sampling techniques can help us with this kind of task. So we have another technique called convenient sampling. This is very, very useful when the data is like the first 1,000 rows. It's quick and it's often representative of the population as long as the population is normally distributed. Now, if you have a very non-normal distributed population or a fat tail or the population is skewed to the left, right, and you have a big population buildup on the left and smaller on the right, or skewed to the right, where you have a big buildup on the right and it's skewed to the left. So you might want to do convenient sampling just to get that part of the population. But again, it always depends on your use case and what you're trying to achieve and what you need to accomplish, right? So there's many ways to do sampling. You really have to understand what the end game is and then go ahead and set up your sampling to meet the end game, right? So there's also another technique called judgmental sampling. This is when we select data based on expert knowledge, such as focusing on specific customer segments. So this could be another way to get specific subset of data that represents the population, but just based on a certain judgment or a certain predicament or a certain what is it called, like bias or something like this, right? There might be a specific reason that you want to take this kind of information, right, from the entire population. So if we have income greater than 70,000 and age less than 35, we're going to filter this data. This filtered data goes over here, Control F. I can just show you right here. This filtered data goes over here. And we're taking the entire length. The entire length of the filtered data is right here. And based on this judgment sample, we are taking a subset of the population. So if I hit Control Enter, you will see income greater than 70,000, age less than 35. So here we have 34. This person is doing good, 18 years old. Income is 83,000. I'll tell you truthfully, when I was 18, I was not making $83,000 a year. I was probably making nothing back then, maybe $200 a year. So this guy is doing okay. And we have another female, 70,000, under 35, right? And income greater than 70,000. So all these conditions are met. So now this is just a different way to take a subset of your data, right? We're taking a probability-based sample of the data because it's just too much information to work with all the data. Like you saw over here, 1,800 videos every minute, 500 hours of video are uploaded to YouTube every minute. If you're looking for specific videos, you can apply a filter and just look at those specific videos. You can't analyze 500 hours of video that come onto YouTube every single minute. It's just not possible, right? We can do quota sampling. This is ensuring that the sample matches a certain population characteristic, like gender ratios. Okay, so if that is your end game, this is how you can do that. This is a data frame. We're grouping by gender and education, and we can just look at these two things right here. If that is the requirement or the task that you need to accomplish, right? So we have snowball sampling. This is starting with a small group and expanding through referrals, often used for niche studies. Okay, you start with a certain sample. Okay, we start with one, and the snowball starts small and builds up and builds up and builds up over time, right? So it keeps going and going and going. And we're looking at new referrals in a region, okay? And we're looking for these records in the region. Control Enter to refresh the cell. Now, if you are working with Salesforce, this would be very relevant, right? If you're working for customer retention or customer recommendation or some type of, I need to contact new customers, which customers should I reach out to first? This is very important, important technique to consider, right? Because you can reach out to the customers that are probably going to conduct business with you, right? And you don't have to waste your time with a lot of people that you're doing cold calls to, or you're doing like random reach outs to people, you can look at this technique to help you to find out which people are most likely to agree to do transactions with your company. Okay, so let us look at a different, let's switch gears now, and we're going to create some charts now. Okay, I'm creating a simple dictionary right here. When you see the curly brackets, this is always a dictionary, and you can tell because you have the key right here and the value. So a dictionary is a whole nother technique. I have another couple of videos on my channel about this. You have a key and a value. It's almost like a phone book. I don't think people really even use phone books anymore, but if you remember this, if you grew up in the 1970s or 80s or 90s, even into the early 2000s, I think they still had phone books. I don't think they do it anymore. But you always have like the person's name and then the identifying information associated with that person, right? So this is the key. This would be the person's name, and then you would have the address and the phone number. That's what you'd have in the phone book, right? So this is the key, and this is the value, and these are paired together. So this is the dictionary. And when we take these key values, we can go ahead and create some plots and charts based on all the information that we analyzed above. So now I'm looking at income greater than 70,000 and age less than 35, right? I'm looking at the judgment sample. If I do Control F, you can see judgment sample. These are the judgments right here. I want to look at the age and a color type will be a sample type, and we have a bar mode right here. So we can look at the sample types, and with these plotly charts, I did this a lot in a lot of my videos, we can click on and click off these different charts so we can see the details here of what's going on, and go down just a little bit. We can turn that off and turn that on. And we have Quota and Snowball, right? So these plotly charts are very helpful for interactive analysis of the data, right? So we have age distribution sampling technique. Down here we have age distribution by gender distribution by sampling technique. Okay, and again, we can click on or click off these different bars and we can see what the outcome is. Okay, so undersampling over here, undersampling. This is gender by cluster, and this is female by systemic. Okay, so we saw systemic sampling earlier, and I can turn on and turn off these bars, and we see one more down here, income distribution by sampling technique. And again, we can turn these things on and turn these things off right here. Okay, and there's another one. So now we see convenience and Snowball and Quota. Okay, so if I turn them on, we can see all these come back, and very interactive and very useful as well. Okay, so these are different sampling techniques using probability and non-probability sampling. And of course, we're working in the Jupyter Notebook, like always work with Jupyter Notebooks because they're very interactive and very easy to set up and very easy to execute and to illustrate the point that we are analyzing right here. Okay, so that's it for probability and non-probability sampling. Hopefully this was informative and educational and somewhat inspirational too. I'm going to share all this code with you guys, and I will post this video later today. Okay, thanks for your time, and good luck with your learning journey. Goodbye.